Hello friends, welcome to my channel. Let's have a look at problem 2484, count palindromic subsequences. In this video, we are going to share a solution based on dynamic programming. So in this video, the DP involves three indices, so we term it as three-dimensional dynamic programming. So first, I'll read through the problem statement to digest the requirement, and then we do the analysis and explain the DP update rule, and finally we share the code. First, the problem statement. So given a string of digit s, return the number of palindromic subsequences of s having length 5. So we need to return the result in the sense of modulo this constant 10 to the power 9 plus 7. So as noticed here, so we consider the subsequences, right? So here are three examples. So in example 1, so the output is 2. For example, we can consider 1, 0. So we have 0, 1 in the end. So we can use either of the two threes. So the output is 2. So example 2, we need to use 2 zeros at the very beginning and 2 zeros at the very end, and then we can choose 1 in the middle. So you can do the combinations. So in total, that is 21. So the third example is sort of easier. So because we have 9 and 10, so one of the length 5 palindromic subsequence is the first 5 nines. The second one will be the last 5 zeros. So that's the output 2. So before we do the analysis, let's also look at the constraints. First, the length of s is in between 1 and 10 to the power 4. So the previous number 1 tells s is not empty, and the latter number 10 to the power 4 tells us that the problem size so is not small. So we need to carefully do the coding or algorithm. Secondly, so s consists of digits. So in other words, each of the characters in s is one of 0, 1 up to 9, right? So that's the problem statement. So now let's look at the analysis. So as we mentioned, we're going to use dynamic programming. So here, the prefix and suffix subsequences are involved. So let's move forward to explain the notion and the idea. So to compute the number of palindromic subsequences of s having length 5, and 5 is an odd number, so we just need to consider the subsequences of format gk star kg, right? Two things to notice. First, so I and j, so we just need to check. This is actually bounded by a constant because both I and j runs from 0 to 9. So the total possibilities is bounded above by 100. And secondly, we don't need to care about the middle character, so as we indicated by the star. So in order to fix the idea, let me introduce some notations. First, pre-IGK is denoted by is to denote or interpreted as the number of prefix subsequences of gk from the beginning of s up to index I. For example, pre-I12 means the number of prefix subsequences 1, 2 in s up to index I. So similarly, the suffix igk is interpreted as the number of suffix subsequences of form gk from index I to the end of s. For example, suffix I12 means the number of suffix subsequences 1, 2 in s starting from I to the end. So if we use the above two interpretations, so to compute the total number of desired palindromic subsequences, so we just need to sum up the following products. So pre-I-1 gk times suffix I plus 1 kg. So here I is in between 2 and n-3, right? Because we need to have 2 before I and also after I. So here G and K runs in between 0 and 9, right? So here we want to return this in the sense of modulo 10 to the power 9 plus 10. So this is the overall idea. So, but in order to carry out this idea, we need to do update for this pre-ij key and sub-ij key. So for this, let me explain the DP update rule. So here I'm going to introduce another two tables or variables. It's called const pre and const suffix. So this const pre-ij means the number of j's appeared in S from the beginning up to index I. So, and the const sub-ij means the number of j's appeared in S starting from I up to the end, right? So for these two DP tables, so it's very easy to do the update. So in general, for example, const pre-ij, we want to count how many j's appeared from the beginning up to index I. It for sure equals const pre I minus 1. So the count up to I minus 1. Then add 1 if the integer at Si equals j. Otherwise, it's just the previous one. So similarly for const suffix ij, it equals const suffix. So notice here, it's I plus 1. So j plus if the current character Si equals j, right? So this is the update rule for the two auxiliary tables, const pre and const suffix. So now let's look at the update order. So first, when we determine pre-ij key and const pre-ij key, we need to first set a smaller index I and then go to the large. So, but when we determine suffix ij key and const suffix ij, we need to first set the larger i's and then go to smaller ones. So the general DP update rule is the following. So pre-ij key so equals pre-ij key I minus 1 j key if the integer at index I of S does not equals to k. So in other words, so the number of prefix subsequences jk up to index I equals the number up to index I minus 1 if Si does not equals to k. Otherwise, we need to add some additional ones. So because we can use we can count how many j's appeared up to index I minus 1. Then those j's can form jk with the current Si because Si equals k. So that's the update rule. Pre I minus 1 jk plus the extra ones. So similarly for the suffix ij key, so if Si does not equals j, then we just need to count suffix I plus 1 jk. In other words, for S starting from I to the end, the number of suffix subsequences jk equals those starting from I plus 1 up to the end if Si does not equal j. Otherwise, we need to count the extra ones, that is count sub I plus 1 k, because those k's after I can form jk with the current Si. So those two items are the DP update rule for pre and sub in the three-dimensional table. So here is a walkthrough. So actually for example 1, the output should be 2. So the const pre and the const sub is listed here. So actually after we finish the coding, you can print out everything. So now let's make a modification of example 1 to further explain the idea. So here I can add another 3 before 1 in example 1. So we get 1033031. So this example, the return shall be 5. So here I'm going to use const pre. So this is the corresponding counts pre table. So here, let me determine one element in pre-ij key to fix the idea. So here I'm going to consider j equals 1, k equals 3, and I equals 3. So we want to determine pre-313. So in other words, I want to determine from the beginning and up to index 3, how many prefix subsequences 1, 3 appeared. So actually this is 2, which is easy to observe, right? So we have 1, 3, and 1, 3, but we want to examine the DP update rule. So we know pre-213, right? 213, so it means, so up to index 2, how many 1, 3 appears? So just once, right? So that is 1, 3 in 103. So now in this case, we know that, so at index 3, so the character or the number is 3, right? So in this case, so we need to check, so if there are ones appeared in front, so in that case, so we can form 1, 3, use the previous 1 and the current 3. So in other words, so we want to count a pre-2-1. So the pre-2-1 is that ending at index 2, how many ones appeared? That is 1, right? So in this case, pre-313 equals this general formula according to the DP update rule. That is 1 plus 1 is 2. So actually for this example, the valid subsequences are listed here. So there are 5. So I listed the palindromic subsequences and the corresponding indices. You can do a self-check. So with that said, so we are ready to do the coding. So I'm going to write with some redundancy to explain the idea. So first, I'm going to introduce some variables. So constant n and result. So the constant will be 10 to the power 9 plus 7. So we are going to compute the final result modulo this number. N will be the length of the string just for convenience, and the result is initially 0. And next, we're going to initialize the tables, right? So notice that for the DP tables, we need to initialize from inner to outer, right? So for example, here 0 times 10. So then I want to first make a 2D, right? For this, so actually I can write this for I in range 10, and then for in range n, right? So this will be our table for pre. So notice that, so this 10 is corresponding to k, this corresponding to I, and this is corresponding to G, and this corresponding to I. So actually you can write G and I. So this is the pre. And then also I want to initialize the counts pre. So which is two-dimensional, which is n times 10, right? So here I'm going to use this 0 times 10. 10 is a column, and then for a dummy index in range n, right? So first I'm going to set this counts pre, right? So notice the interpretation, right? So for I in range n, for j in range 10. So we want to count how many digits j appeared in S up to index I. So for this, if I equals 0, so we just need to set counts pre ij. So we just need to check if let's see, if int s I equals j. So if it equals j, so just set 1. Otherwise, it remains 0. So let me write else 0. So otherwise, so what we are going to do is count pre I j. First, we include those counts. So pre I minus 1 j, And then we want to determine if we want to add 1, depending on whether the current digits equals G. So that is int. So if the current SI equals G, right? So I'm make this to be int to make it a 1. So this is the DP update for this const pre. So now we can actually first set this pre table. So for this, let me do this. So let me make some remarks here. Set up the const pre. So next is set up the pre. So this is 3-dimensional, right? So we are going to for I in range n, right? So first I'm going to get the corresponding character digit. So int si, right? And then we're going to we just need to check for I greater than 0 because we want to check I minus 1. So for I greater than 0, so if I greater than 0, then we're going to check for all the possible j k. So for j in range 10, for k in range 10. So for this one, so we want to first get pre I j k. It at least equals pre I minus 1 j k, right? So next we want to check if we need to add some extra counts. So in other words, if k equals the current c, so we want to add or increment this guy by counts pre. So we want to check before I how many j appears. So that is I minus 1 j, right? So for this we set up the counts pre and the counts and the pre. So next basically we want to do a parallel thing. We want to set up the counts sub and the sub. So now let's do set up the counts sub. So this is actually very simple now. So let me first copy this part because these dimensions are the same. So I want to change this to be sub and change this to be sub. And then let's first do the setup. So for this, let's first set up the count sub. So for I in range n, and for so here not so because we want to reverse. So -1, -1. Then for j in range 10. So first, if I, so this is j, if I equals n minus 1, right? So we just need to count if int si equals j. If so, count sub ij will be 1. Otherwise, it remains 0. Else, so we want to set counts sub ij. At least they have counts sub I plus 1 j, right? And then we just need to count if the current si equals j or not, right? So in other words, if it equals j, so we add 1, otherwise not. So this finishes the setup for count sub. So next, let's set up the sub. So for this, we need to do in a reverse order for I again. For I in range n minus 1, -1, -1. Then, so first let's get the character int si. And then what we're going to do first, if I less than n minus 1. So if I equals n minus 1, there's no I plus 1, right? So for j in range 10, for k in range 10. So we want to consider how many suffix gks after and including index I. So for this, let's first I, J, K. It's at least this many, right? I plus 1, J, K. So next we want to check if we need to add some extra ones. So if J equals the character, and then we want to check how many keys after I, right? So we are going to increment this guy, ijk, by const suf, which we have set up. So it should be after I, right? So because we want should be after I because we use character S. We use the character at C as G, right? So here should be I plus 1. So we want to check how many keys in this case. So that is I plus 1 key, right? So this way we finished set up the suffix. So next we do the counting, right? So we want to fix the middle one and consider the length 2 prefix and the length 2 suffix. So we have already set our result variable, right? So for I in range 2 and n minus 3, right? And let's say n minus 2. And then what we are going to do is just check for I, for j in range 10, and for k in range 10. So what we are going to do is that, so we increment the result by pre I minus 1 jk times suf I plus 1. So because we don't care about what si is, anything will do. So we want to see how many gks before index I and how many kjs after index I. That is kj, right? And then we after this, so we just need to return the result modulo the constant, right? So that's the whole logic for this problem. So basically we do two parallel things. First we set up the const pre, and then we set suf and const suf, and then we do the counting, and finally we return the final result desired by the problem statement. So I guess up to now, so we are ready to do a check. So this is the special case for 3. Let me check for example 1. Yeah, it returns 2. So now let me add 3 here. So you can see it returns 5. So with that said, so we are ready to check for the generic cases. Yeah, so yeah, it passes all the cases. So let me test again. So it should be fast enough. Yeah, it passes all the cases. So as we mentioned, so this problems we used 3D dynamic programming. So you can actually print out the tables to digest the idea. So actually another problem, Leetcode problem, which we solve used 3D dynamic programming is the generic stock buy and sell problem. You are also welcome to check out those videos. So with that said, I guess that's about it for this problem and this video. Thank you.